Now we can start.
Yeah.
It is streaming. Abhilash sir, it is streaming.
Yeah. Thank you. So, okay, it is already 3, right? Yeah. Good afternoon all.
Abhilash, am I audible?
Yes, sir. Shall we start, sir?
Yes.
So we'll start. Good afternoon to all. As per the Indian Standard Time. So this is the 8th lecture in the weekly online lecture series of radar meteorology course conducted by South Asian Meteorological Association in jointly with Advanced Center for Atmospheric Radar Research, Cochin University of Science and Technology. So today we have an eminent speaker from IMD, Dr. R. Suresh, and today the welcome address will be proposed by our chairman of this radar meteorology course, Dr. Devendra Pradhan sir. I request Devendra Pradhan sir to propose the welcome address.
Thanks, Dr. Abhilash. Good afternoon to everyone who is there in this webinar, which is being organized by this South Asian Meteorological Association. Many thanks to the President, Sama Dr. Ajit Tyagi sir, Secretary Dr. Someshwar Das ji, and all others, those who have organized this lecture series towards the radar training here. And today's one of the very important lecture is being delivered by Dr. R. Suresh on the aviation applications. Before Dr. R. Suresh, so many lectures have been conducted for the introduction of the Doppler weather radar, its products, and many other things which have been taught from the basics of the radar meteorology till the point where we can understand many things with respect to the aviation utilization of the DWR products here. So I welcome my guru, Dr. R. Suresh, who has taught me many things in the field of meteorology and especially in the Doppler weather radar. I invite and I welcome Dr. R. Suresh, and I express my sincere thanks to him for joining this lecture series here. Dr. Suresh sir, we will be grateful to you, and we all are here just to have your experience being shared through your lecture. Thank you very much, Dr. Suresh, for joining us, and thanks everyone who is there in this meeting webinar here. Thanks once again. Thank you very much.
Thank you, Pradhan sir. Now I request President Sama AVM retired Professor Ajit Tyagi sir to deliver the presidential address. Ajit sir.
Thank you, sir. We are not hearing you. Thank you, sir.
Hello?
Yeah, so now it is.
Yes, sir. Yes. Sir, you are in mute. Sir, you muted. Sir, please unmute.
Yeah, you see, there is some problem with the audio. So
Okay.
I'm
Now-
logging from.
Okay.
Is it okay now?
Yes, sir.
No, it is. Yeah. Yes.
Okay, let me log out from.
Some feedback is coming from your device.
Yeah, you see, I tried from mobile. Just give me a minute.
I think you have opened from two devices,
Yeah.
so feedback is coming.
So I have logged out now from one.
Yeah,
I
yeah.
tried,
Now it is fine, sir. Now
Now
it is
it's
fine.
fine. Now it's fine.
Now
I
it's fine.
tried from mobile. It was not audible. I was not audible, and
Uh,
so I've now from my iPad. So I'm logged out now. Thank you. Sorry for this glitch, and thank you. May I do my opening remarks?
Yeah, yes, sir. Yes, please.
Thank you, Abhilash, and it's a great pleasure to welcome speaker of today's lecture, Dr. Suresh, and of course. We also have Dr. Pradhan, the chairman of the organizing committee, Vilash, Swagata, and other organizing members. Welcome to all the participants. Well, this is the 8th lecture in the series of satellite met, radar met online lecture series. We had first 4 lectures on the basics delivered by Dr. Pradhan, Kannan, followed by a lecture on cyclone by Dr. Reddy, then on thunderstorm by Dr. Pradhan, and now today we are going to have a very distinguished lecture from Dr. Suresh on the aviation meteorology. See, this is very important application of the radar, particularly the airports where a lot of activities take place, and the use of these radar inputs in the local management of the air traffic is very vital. Dr. Suresh, I'm sure Dr. Pradhan must have introduced to him. It is a very versatile operational forecaster, radar specialist, aviation meteorologist, and a very good administrator. And it was a great pleasure to be associated with him as a colleague in the IMED. And he is a thorough professional in his approach. So I'm thankful to him that he's agreed to deliver this talk. With his vast experience both as an aviation meteorologist and a radar specialist, I'm sure participants will immensely benefit from his lecture. So thank you, Dr. Suresh, for having agreed, and please keep continuing to support the Samaj activities and also guide participants. We are inviting them to get in touch with our resource persons even after the lecture is over. No doubt we'll have a question and answer session, but if they are left with some doubts, they may like to get in touch with you also. So thank you so much, and I'm sure that this is going to be very, very learning experience for all the participants, so make best use of it. Thank you, Jai Hind.
Thank you, sir. Thank you very much for the presidential address. So now I invite Dr. Paulomi to introduce. Though Suresh sir is not required any kind of introduction. He is my teacher as well. Maybe we have association for the last since 2022 onwards, and now I request, and he is a member of our board of studies in CUSAT, so in designing the syllabus and all. So now I request Dr. Paulomi to introduce today's speaker.
Thank you, Dr. Abhilash. And it is my with great pleasure to introduce Dr. R. Suresh, who is a stalwart in the field of uh, radar meteorology. And he is also a scientist F and Deputy Director General of Meteorology, retired from the IMD. Dr. Suresh has vast experience in the field of aviation, satellite, and radar meteorology, along with thermodynamics and statistical forecasting techniques. His contribution was instrumental in developing Doppler weather radar algorithms for India weather conditions and played a key role in ISRO IMD's indigenous DWR development project. Dr. Suresh was actively involved in the planning stages of the GPM satellite mission and Megha-Trophic program, as well as for the introduction of national aviation significant weather chart in digital form similar to WAFC products. Along with this, Dr. Suresh has Dr. Suresh has introduced online aviation meteorological briefing in the country and quality management system QMS ISO 9001-2008 on aviation met services provided by India. Dr. Suresh also continued to function as Indian focal point and working group member for services information exchange of ICAO and contributed significantly towards it. Awarded with the Certificate of Merit from the Ministry of Earth Sciences for developing the online aviation meteorological briefing system OLBS in 2007 is only one of the feather in his cap. He is also actively involved in extracurricular activities such as he has served as the chairman and secretary of the IMS Chennai chapter and as a national council member from 2001 to 2003. He currently serves as a chairman of the IMS Chennai chapter, and it is with great pleasure that SAMA, jointly with ACARR, Cochin University of Science and Technology, we welcome Dr. Suresh to this online session of the Radar Meteorology lecture series. Thank you so much, sir, for joining us today, and we are looking forward to your lecture today.
Thank you, Paulami. Now I request Suresh sir to deliver the talk.
Thank you, Abhilash. Now I am putting my screens once again on. I don't know whether I already clicked in, but still it has not come. Resume. Is it visible?
Yes, sir.
Yeah, sir.
Yeah. Anyway, very good afternoon as per Indian condition of local time. And then thank you for all the speakers who welcomed me and then introduced me. And this particular topic, as it is, though it is DWR products for aviation, I'll be concentrating on, because radar itself only for aviation, what to speak, what not to speak, there is a small thin line of differentiation. So that is why I'll be covering in depth of whatever within this 1 hour period within my reach. So maybe Abhilash, the caption title is being masked here. Okay. So now I'll be just taking here. Before going into detail, I'll be dedicating this lecture series to 3 veterans. Mr. Raghavan of Chennai, who was considered as a think tank of Indian radar meteorology, who has written a book on radar meteorology with a Clover publication way back in 2003. And then Dr. Sikka, ex-IITM director, who was instrumental in quality observations and promoting a lot amount of research in Indian arena as well as international also. Third one is Professor TNK, my esteemed great high NWP modeler, who was using all the radar products sometime, and then he was praising my radar works earlier, and then he used our rain rate, about which I will come on the penultimate slides. So I presume that already this lecture series is on, and then with that probably the radar concept has been introduced, and then how the radar has evolved from analog to digital to Doppler, and then probably how the moment generating functions will be in a position to get the Z, V, and W or sigma data, and all the products innumerable. All this one are told to this. This is the prerequisite from my side. Probably now I am taking for granted that they are all covered in the earlier sessions. Now, in this session, I will be covering only 3 topics. Within the 3 topics, whatever I highlighted here, convective storm, which is inclusive of thunderstorm onwards, hailstorm, severe local storms, cyclonic storms. Because this is vulnerable for aviation, that's why I am concentrating much on it. There will be as many as 6 cases of thunderstorm, and then 2 cases of cyclonic storm, and then 5 cases of hailstorms. I'll be covering in a nutshell. And then I am giving enough references wherever it is feasible, wherever it is warranted. The second topic which I will be concentrating on, low-level wind shear and associated turbulence. The third one I will be covering on the rain rate and deteriorating visibility. So with this small introduction, I take for granted these are all the products which are available from the DWR, probably which have already been well covered. Now, this is a fascinating cartoon. I have put some 3 or 4 cartoons from the radar meteorology book by Reinhardt way back in 1993, 99, and then 93 was original book, 99 was the second edition. For each of what you call radar products, inference and something like that, people, we have to know that how it is going to be useful. So for that, we should have continuous monitoring. For the continuous monitoring, probably, the first cartoon itself says, does it look like a hook echo? Or an inverted comma, something like that. One scientist is asking, the other one is saying that I was going to say that it is about a butterfly. So this sort of what you call a jovial way he used to say. So this interpretation is tricky. That's what I want to give from this cartoon. The second one, probably we should have continuous monitoring that is being established in the second cartoon. Now coming to the thunderstorm, probably you have single storm, single cell storm, multi-cell storm, then superstorms, etc. And probably know how a thunderstorm is getting evolved in the life cycle. That also probably as a meteorology person, we are supposed to know. In the radar parlance, how it is going to come. In a nutshell, I will be touching here and there. As a useful for the thunderstorm for the aviation, probably the pilots have been advised by the training academy of the pilot school that as far as possible, try to avoid 40 dBz and above. Why this is there? Probably it has some relevance with the vertical development as well as the rain range. And I have given the reference always in the pink color with italics wherever it is relevant. So those references are available. Probably whomsoever is interested, you can very well go through. A very wonderful account has been given in 1990 by the American Med Society Radar Med Conference, 40th anniversary conference. It is a celebrated textbook compilation of more than 38 chapters, if I am right. So within that, you have probably around some 874 pages. Everything has been covered in a nutshell. Probably if one is interested, you can very well go through. These are all available online as well nowadays. Now coming to the thunderstorm family, the second one is a severe local storm. Here the distinction maybe it produces hailstones. The hailstones can be of two way of definition. One school of says then it is about 19 mm. Second school says that it is 25 mm and above. And the severe local storm covers Deraco also. Deraco probably in the South Asian countries, we are not that familiar. These are all only vulnerable in the European context. That name also coined from the European side. It is nothing but a high wind storm. So here probably for the radar surveillance, the wind is a biggest enemy for the aviators as well as the thunderstorm group also. So that's why I have kept on slide here like this. Now coming to the common way of educating the students, maybe in about some 30 minutes period, how this thunderstorm cell has evolved right from about some 2000 feet base height going up to 40,000 or 45,000. In the southern peninsular India, wherein I am sitting in Chennai, so it is normally going even beyond 67,000 or 22 kilometers in height, exceeding the tropopause. So thunderstorm will be very, 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 very problematic for aviators just because it has the vertical growth, it has associated updraft and downdraft, it has ice, and then it has turbulence. So that is why these set of models, etc., probably with the radar concept, how it has evolved. One slide I had devoted here like this. From now on, only from my own papers and then work, wherever relevant, that I'll be quoting at. Now, this school of audience already have been ushered into how to interpret the radar data, radar products, etc. So now I am putting a slide before you. You can see the left-hand side slide is about 3 minutes earlier than the right-hand side slide. In 3 minutes period, the cell has developed from 6.5 kilometer to 18 kilometer and overshooting beyond 18 kilometer. If that be the case, whether the tropical convection, which we are seeing now in the comet slide, in about 30 minutes, it has grown even up to some 12 kilometer, 40,000 feet. Here it has exceeded that also. Whether it is the reason or any other reasoning. So coming to the answer for that, in 3 minutes time, how it has evolved, one can immediately see normally the settable parameters or the display parameters everyone has to take care of. The left-hand side and then right-hand side, all the parameters one has to see before using it. This is applicable not only for radar, but also for satellite product as well. So the left-hand side figure is drawn from 250 PRF or 600 kilometer range. Chennai radar is supposed to be the unique in its kind because 250 PRF was working well even till the last day of the radar. Even now also it is working. I cannot say till the last day. After that we have got upgradation, that's all. So 250 PRF, because 600 kilometer, there is no point of increasing the elevations. We have only hardly 1 or 2 elevations or 3 elevations. In this particular products, 0.2, 1 degree and 2 degree alone I have put in. So that is the reason the height has been restricted. Because for 600 kilometers, there is no point of giving 4 degree or 20 degree or 15 degree elevation, because it will go to 40 kilometer heights. So we want to have the surveillance because of the earth curvature effect and other thing. Probably we are putting minimum elevation for this one. That is the reason the height has been restricted here. Whereas the next one, it is 500 PRF scan, which is covering 300 kilometers. So that is why it has overshot 18 kilometers. So that is the reason. So this is the product interpretation which I wanted to just inform to everyone. Then the second case, because for aviation, how it is useful, probably you can very well sense. Because of the height vulnerability within the CB means, as WAPS is used to say, World Area Forecast System used to say, thunderstorm means it is inclusive of hail, updraft, downdraft, turbulence. So that is why the thunderstorm is very, very vital. I will reveal the climax only after some time. Why I am concentrating thunderstorm first, then taking you to the wind. Now the second case is again a thunderstorm case on 17th April. For that, I am taking care of all the thermodynamic parameters. So these thermodynamic parameters, whatever is favorable, it is my own style, red color. Whatever is not favorable, black color or any other color. So most of the parameters are favorable. Now, everyone has been ushered into max Z or CAZ, that is the maximum projection of reflectivity. Whereas in this case, I am purposely projecting maximum projection of spectrum width. Spectrum width, in our parlance, we used to say W. In next rad parlance, they will be saying sigma. That's all. Sigma or W, anything you could call. The spectrum width of more than 4 MPS, it is a moderate to severe instability. More than 5 means definitely it is a severe instability. For any cloud development, you require instability to be prevailing. So that you are already testing with the GPS sound or radio sound with the 0 UTC and 12 UTC, whereas with the radar, every 5 minutes you are testing it. So that is the reason I am putting the spectrum width here. You can very well see the spectrum width as if a line or something like that is there, wherein the red color, which is showing beyond that 4 MPS or something like that. Here the line is very much formed, and then there is a difference of 26 minutes between these two timing. Everything has been captioned. Now for the same scenario, after 26 minutes, how the reflectivity has increased. Earlier one was instability, now it is the reflectivity. You can very well see there is a line squall. So line squall by definition, it is more than hundreds of kilometers of length, and the length is to breadth ratio is 10:1, and then it is maybe not necessarily a straight line, it can be a curvilinear. It will be producing enough downdraft, rainfall, hailstones, etc. So in a line squall, if an aircraft flies, you know what is the fate. So that is one of the reasons this sort of alert through our aerodrome warning or segment warning in the real time we were giving. All the cases, whatever I am showing, they are all real time cases. So now I am just comparing the earlier 2 slides and another 2 slides with the 26 minutes difference. So with the 26 minute difference, you can see that 10:28 UTC, 10:54 UTC, how this area has been captured with the reflectivity, which is a line squall. The second one, another time, 10:58, 11:24. So the line squall also has been captured. You need not always depend only on radio sound, which may be once a day ascent or twice a day ascent or sometimes no ascent at all. This is quite possible because each ascent costs the exchequer about 20,000 rupees in Indian currency. So to that extent, probably some of the countries may not be releasing even twice. India was rich enough to release 38 stations twice a day ascent. But there are cases, there were cases, there continue to be cases, not all the 38 will be reporting the GPS on. If that be the case, as an aviation forecaster, what you are supposed to do? So that is why the radar given, I am saying that whomsoever is working with the radar, this product is available with you. Whereas in the internet, what IMD, we are suggesting that we cannot give because there are as many as 45, 48 products available. We cannot put everything online. So we are putting hardly 4 or 5 which are reasonably reliable, out of which the maximum reflectivity is one of the things. What is the advantage? Probably somebody might have already covered with you. So it is nothing but a multiple elevation, probably put in a 3-dimensional form. a plan view which is projected in the center, and then bottom to top in the top projection, west to east in the right hand side projection. Now with the Doppler spectrum width, whatever I told you, I am giving the reference also, more than 4 meters per second as per Wilson and Wilkes. It was supposed to be moderate to severe. That's what I told. Reinhardt was saying severe turbulence was 4.8. And Dovia against Renich, who is the doyen of radar meteorology, he was saying that even in the tornadic storm exceeding 6 meters per second in 28% of the cases. In our Indian parlance also, whatever I have highlighted here, that also I am giving it here. Maybe, what we can think of, whomsoever is working with the radar, you can very well use it. Now I am giving an animation which is starting from 6:15 to 12 UTC. This is the third case, because I mentioned about the sea breeze. Now you can see that how sea breeze has been well captured. So this is the sea breeze. And this sea breeze without any induced convection, because you are not in a position to see on that day any CB clouds. Whereas the next one, what I am going to say, with induced convection, same sea breeze, very next day. So that is why immediately one can very well get it. That's why I am giving this set of examples. So in this sea breeze, a cloud has developed. You can watch this area, cloud is getting intensified, and the cloud also propagates, because for cloud development, you require wind discontinuity, which is being given by the sea breeze. Then moisture has to be there, that also can be advected by the sea breeze, or otherwise an anticyclone over the Bay of Bengal that pumps the moisture. So all the cloud development, in case hygroscopic nuclei are present, the earlier day it was not there, the very next day it was there. That is why this is a contrasting example. On 2 successive days, both the days sea breeze was there. The first day it was reducing the temperature of Chennai by about 7 degrees or so. The second day it gave even thunder rain. The fifth case is thunderstorm rain around Chennai on northeast monsoon day. 0 ETC, not at all favorable. That is why I have not highlighted any of the thunderstorm parameters, that is thermodynamic indices, in red color. All are in black color. That shows that they are not in favorable condition. Whereas how it got reversed in 12 ETC. You can very well see that all the red color have come in. That is the George K index, TTI, dry convective index, precipitable water content is available. That is a must. Okay. So with this, so now going to the radar products. Fortunately or unfortunately, probably the earlier products on this particular day, I am not having it. Only at the dissipating stage, I am giving this as a picture. This is the radar center. This is our MO Chennai. That is the airport, Chennai airport, which is around some 16.5 to 16.8 kilometer radially away. So that's what I am giving. This is the dissipating stage of a thunderstorm, which has started its journey right from 12 UTC on the previous day. That is 13 UTC, the first TS was recorded, and it lasted up to the next day, 2 UTC. Because this is a northeast monsoon. Northeast monsoon being pulsatory, you have a cumulonimbus cell continuously coming in. Maybe the Madden-Julian oscillation or something that whomsoever studied, and then what way it is relevant, you can very well compare. So for more than 15 hours, thunderstorm was occurring, and then it recorded. I am unable to show the picture because it all got correct. Now, in addition to this one, probably you can see how the wind variability is there, the color changes. So around 0.5 kilometer, which is being very close to the radar, so you are having only 3 MPS. Whereas around some 3 kilometer height, the wind is increasing to 14 MPS. You can convert into knots by multiplying by 2. And the rain rate also how it has got, and then I have got a precipitation accumulation over a period of time wherein the thunder was there. The sixth case is a squall line, and then it's an isolated thunderstorm case. And it has some relevance with the Jet Airways, one of the airline, whose ladder was about to be anchored to an aircraft immediately on arrival, so that another passenger can alight, and then they will be taken by bus to this one, because it was not having the weighbridge type connectivity on that particular day due to other engagements or something like that. All the main things were engaged by some other airlines. So they were anchoring the ladder. It got drifted with the squally wind. So that is why I am putting squall. Those of you who studied meteorology, you are aware what is squall, what is a squall line difference. So squall is only a wind phenomena which is exceeding more than 23 knots and then lasting for minimum 1 minute, crossing some 3 stages of buffer, or exceeding 15 knot difference from the previous one. All these definitions have been well captured in this particular slide. So here again, T5 gram, and then the parameters. I cannot give it this because this image, I cannot bold it as a red color here. All are favorable. So here again, you can very well see how this probably a particular squall line, which is having only 6 kilometer height. The reason, as I already explained, this being near to the radar by around 16.5 kilometer, even with the highest 21-degree elevation, you will get a height of only 7 kilometer or so. So that is what you are getting it. In fact, actual cloud was more than 14 kilometer because once it has traversed beyond Chennai, the range increase, we are also getting the higher tops. So in this particular case, how the squall line has given the downdraft, you can very well see the positive velocity, negative velocity. Already this has been ushered to you. You can very well see the radial velocity difference, and as per Fujita or Browning, etc., it is almost a microburst and macroburst put together. That was one of the reasons how the radar got drifted away. Thank God it has not hit over the fuselage of the aircraft. It has fallen only. Now a small animation, every 10 minutes it is getting changed. You can see how the wind variability, that is the radial velocity variability is there. So this is what I was saying, that microburst thing has crossed out. Now it is a macroburst. Here it is an animation from 8:58 UTC to 10:18 UTC. Based on this, aerodrome warning alone, as I told you, it was an isolated case. There was no necessity for a segment warning. So we issued aerodrome warning, and probably, even with that also the anchoring, etc., because they have landed, and then that way, probably, everything went on well. Fortunately, there was no accident on this particular day. Now our CWIS, that is current weather instrumentation system, which is having 1 minute average, 2 minutes average, etc. You can see I have bolded in red color. So it is qualifying as squall. 1 minute average exceeding 23 knots, it's a squall. So you can very well see that for more than 4 minutes, 10:00 to 10:003, it was a squall. Now, after the thunderstorm case, I am taking one cyclone case. Another cyclone case I am reserving at the penultimate. So this is an Nilam cyclone because this is a fantastic classical example how the radar data can be used for aviation purposes, especially in the recent time we are closing the airports. During those periods, we were not in a position to close because for closure of airport, we have to get the permission from the parliament. So during that scenario only, you have to think of. And then under this situation, what we were working, that's what I'm giving. This is an anecdote of how the TCAC was giving the bulletin. And this is the radar picture of that particular storm. Where it has crossed, I already written over here. It was south of Chennai, Mahabalipuram, a place which is about some 45-50 kilometers radially away. So based on the TCAC bulletin, we started issuing the segments. And in the segment itself, you can see classic example. It was moving very slow westerly with 2 knot speed. That is almost constant or stationary. And it was based on 21 UTC of the previous day, that is 30th. And on 31st 0 UTC position, that was expected to move northwest 12 knots. Perfectly, it was 12 knots and more only at the time because we ourselves calculated. And thereafter, after crossing, etc., only the CB clouds that we are giving with our own stationary. Now, in this particular case, why I am concentrating? Because it covers both wind as well as reflectivity as well as the wind. Wind in the sense that I am talking in terms of folding now. So here is the classical example of folding. In this particular folding case, what you are seeing is for 1000 PRF with our radar of S-band, which normally we consider as 0.1 meter or 10 centimeter. Strictly speaking, it should be 10.43 centimeter or 0.1043 meters. So that is why for 1000, it should be 25. Instead of 25, I am putting it as 26. That is a perfect way. So folding, you can very well see at this particular time because the 1000 Hertz PRF was insufficient to capture it. And probably beyond folding also, it should have come even within that one. You can very well see small dots of blues. That is the second stage folding. So that is why I am giving even the actual could have been very well beyond 33 meters per second. Now we change the PRF because being near, on that day dual PRF, we could not operate due to some reason because it was in a different scan or something like that. So we changed the PRF, we increased the PRF, thereby we were able to get the unambiguous velocity maximum up to 31.3. And in this particular case, only 30 MPs was there. That is why no folding, perfect blue is matching. So based on this, probably now what we can do for the aviation, we can very well say that at this particular height, this can be the wind. So through the ATC, if you communicate, probably vectoring of the aircraft that can be done by the ATC, that is their job. So this way also one can help. Now, based on the radial velocity with VVP algorithm, this, that all, and then probably you can estimate where I am putting here, maybe around 0.3 kilometer to 0.4, 0.5 kilometer, it is 40 to 50 knots. So that has been well done. Why I am concentrating this particular Neelam storm is that in the real-time experience, just 2 days earlier, so there was one Sandy cyclonic storm, which has caused 4 airports to be closed in US. So the same way our Indian airline people also, they started through the operational forum, that is Airport Authority of India, then Airlines Operation Committee, IMD also, we are there, DGCA, all the member stakeholders. We had a meeting right from 28th afternoon, and then thereafter, whatever was there based on our numerical weather prediction model output. I used to use always GFS at the time. So GFS model output and radar product output, we used to say. And then probably, this airport was not closed but for 30 minutes when the cyclone was exactly having the severest wind form. Otherwise, the airport was not at all closed. And because the runway was favorable for this particular storm, being the storm south of Chennai, it has to be easterly, and then runway has to be 0725. So that was very much favorable. Had it been reversed as a crosswind, probably I would have lost my job or I would have been fixed. So perfect forecast, etc., whatever we were giving, probably we got a full satisfaction with that, this particular storm. Aftermath of Sandy storm in US, the severe intensity of both the storms, because I have shown you even 33 meters per second. So that was also only around 1 kilometer. So that set of severe storm, definitely it could have caused a lot of havoc. Had it been a cross storm, we would have been closed. We would have closed that airport for more than 3 or 4 hours on the day. So this is the pictorial way how that wind was gusting here. So this also I am saying main wind was 29 knots and then gusting was, this was what exactly we are given, easterly 30 knots gusting to 40. All the airlines pilots, they were being told, be careful, be cautious landing because it's a headwind. With a headwind also there are some restrictions, though 40-45 knots they can very well meander, they can very well go through. So that is what is exactly happened in this particular case. Now, after these convective storms, only one cyclone is pending. I am taking you for the hailstorms. There will be 5 cases. Chennai, as per the climatology, we have 0 frequency, even today. But aftermath of radar installation way back in 2001 September, operational on 20th February 2002, 2002. The date is very fantastic date. After installation on commissioning of this radar, we have not less than 30 or 40 hailstorms. Climatologically, 0. Why it is 0? Because either of the observatory, Meenambakam or Nongambakam airport or the Met Center observatory, they have to physically see the hail, then alone it will go into the climatology. That also only 0 UTC and 12 UTC. Whereas hail will occur at any time, 949 UTC, and not necessarily over the observatory. That is one of the reasons why Chennai Observatory was having 0 climatology on hailstorm. This I have written over here. So in this particular case, pre-monsoon hailstorm, and is quite vulnerable, very nearby Chennai, etc. In case there is a sea breeze which is giving a favorable condition for the CB to develop, and then this is the place wherein a hailstorm was occurred. Whereas what I am writing as Villivakkam, which is hardly about 7 kilometers from the radar. So you can very well say within the what you call cone of silence, you will not get enough data. That is one of the reasons you are getting the height limitation here. This particular hailstorm I want to keep for one reason, that is, you are having a divergence at the foot or the base of the clouds. And the divergence was the order of 4.3 meter per second per kilometer. That is why 4.3 10 power minus 3 per second. Normally the direct divergence and vorticity, you have to have the order only or the unit only as per second. For interpretation, we will say meter per second per kilometer. So that is nothing but 10 power minus 3 per second. And the convergence was favoring the CB development. The divergence at the foot, this was matching with the record hailstorm in the literature till then. That is the Raymer hailstorm in Colorado in US. That was having about 4. And prior to that, with the surface observation in the thunderstorm project, bias, I think most of you who studied meteorology, you are hearing this particular name. Probably all the thunderstorm structure model, it was given by this one based on the thunderstorm project. So the thunderstorm project, even 1947, they recorded 5 meter per second per kilometer, though it has some element of doubt because at that time, how they were doing it, they are all only with a Bellamy grid or something like that. That has got its own limitations. Now coming to the second hailstorm, the earlier hailstorm, what is the size, what was the time, etc. We are not knowing it because it is not observed by the observatory. It was far away. So people, the media, electronic and print media, they will be saying anything, probably that we have to bear with. But in this particular case, an observatory, which has been well recognized by the WMO, as well as the Indian Defense Service, Indian Navy, that is Arakonam Observatory, which is about 60 kilometers away from radar in the southwest direction, if I am right, or exactly west, that way. So their logbook also I collected because during this period, I was conducting a orientation program for Indian scenario. IMD, IITM, all the defense people, IAF and the Navy, they participated. And then on this particular day, we were having the class. So in between, I was just going, delivering lecture and then going and seeing. I was also puzzled because by the time I was quite novice. And with that only probably later on consulting a literature, we fine-tuned the Indian algorithm for Doppler radar, which has been implanted in our Chennai radar as well as other radars, as well as the ISRO IMD joint development radars as well. So here in this particular case, the hailstone, being an observatory, they have recorded 10 to 15 mm size. And the precise time also they have recorded. So with this, I am giving, this as 3 important points as far as I am concerned. And the reference also I am giving it over here. So naturally, all these thermodynamic parameters were favorable. And probably one of the hail detection algorithm is echo top of 45 dBz. It has to exceed at least 1.6 kilometer above the freezing level, then 10% probability for hail. So like that, there are some charts. So with this particular concept, all these algorithms, etc., they have been studied. And way back in 2004 only, I published this as a paper by interacting with the Witt et al., who developed Build 9 algorithm for NextRad of US. So I interacted, I had some communication with him, and then even probability of severe hail, POSH. So there also we contributed, and then with that also they have improved the pass probability as well. Now in a nutshell, how in a PPV of 0.2 degree elevation, how the hailstorm was there. Hail definitely for aviation parlance, it is very dangerous. Though I am not showing so many pictures due to 1 hour restriction time and something like that. I also have got my own limitations in that. So hailstones, once it is impinging on the aircraft, it will be denting, it will be even making a hole. There are in the internet literature, you can very well see there will be so many pictures available. So that is why the hailstorm, if it is occurring, probably even if you are having some idea, though you are unable to forecast about 6 hours or 12 hours ahead of you, exactly the location, etc. Maybe in 2 hours where it is going to come, you will be in a position to have the track product, which is also available in most of the radars. There is one algorithm which is saying about the gust front. The gust front is nothing but from the downdraft base of the clouds with the prevailing wind, if there is a discontinuity line, that is nothing but the gust front. Why it is relevant? In the gust front, the future storms will develop. That is almost like your CISK, conditional instability of second kind. So here in the radar, the gust front algorithm uses only the radial velocity data along the radial, along the elevation. So with that, some algorithms. So that is what I have given over here, how the gust front have been able to say where it is likely to be. So this is the area wherein it is going to come. That is the Arakonam, ARK, it is written over here. So in a nutshell, how different time periods, how the max Z is involved. This way, am I to answer? Somebody is raising the hand, or shall I postpone it till the end? Okay, I will reserve it for the end of the day.
Sir, there is a Q&A session planned. So
Yeah. That's what I'm
after
saying.
this
That's
lecture.
what I'm
Yeah.
saying at the end of the
Yeah.
lecture.
Yes.
So
Yes, sir.
here, how the reflectivity has got increased, that is why I'm saying that 18 kilometer, 20 dBc itself has gone. 20 dBc, why we are given? Because it is almost corresponding to 0.8 mm per hour or 1 mm per hour. But whereas the actual clouds, I am not saying about innocuous clouds, non-rain bearing or drizzle type clouds that can have even lower than 20 dBc, that may be 8 dBc or 4 dBc or 5 dBc. So that has gone on that day even beyond 22 kilometers in this particular case itself. And then earlier, my think tank, what I was saying, Raghavan sir with analog radar, he has documented 23 kilometers in Chennai with analog Mitsubishi radar long back. So we also seen so many times 22 kilometers overshooting beyond the Trappa Pass. So you can very well see how the reflectivity has gone and the core has increased beyond 57, beyond 60, beyond 62. So that naturally has the hailstones. The hailstones of what Arakonam Naval Observatory has recorded is 10 to 15 mm. That also we were estimating through the NextRad build 8 algorithm. With build 9 also we expected, and it was perfectly matching with our concepts. So this is again the same picture, one of the same picture I am giving for easy reference. In addition, in some of the radars, you are having something like what you call a tracking product and a hail detection algorithm product. Here we have something as probable, something as very probable. If you increase the value, probably you get only thing changed as some of the area getting minimized. So long as you are increasing this one or you are increasing the height. Suppose the freezing level is around some 5 or 5.5 or 5.8 kilometer, because this being a pre-monsoon, it will go even jolly well 5.8 kilometer. So this will be going even to 6.2 kilometer above. That itself suggests that it may be more than 70% chance for a hail. So that is why this algorithm says that this area will be having a hail. So beyond 50% chance, they will be having most probable. Now in MaxCUSAT product, after having seen, you can have a vertical cut, which is a replica or even higher than what RHA we can have. In the RHA, you have to start necessarily from the radar, whereas vertical cut, you can cut from any point to any point, peeping through the storm. So at this particular case, where the storm base is there, so nearby that particular area, if you are going and then making a cut, so that is why I am putting the axis coordinate as similar to our dynamic meteorology. Left hand side is negative, right hand side is positive. That is why the left hand side you are having, and the south side is negative. Both are in the negative because this is the radar. We are in the south of radar. So here we have cut it. So after cutting, I am getting the signal. So now coming to the climax part of it, there are three things which I wanted to say on this particular hailstorm, because this will be useful for anticipating a hailstorm in the genesis stage itself. The first and foremost is the BWR, that is the bounded weak echo region, or otherwise it's called as echo vault. Why it is so? Because in the updraft, it will be moving very fast, and then with that fast, probably even the radar scanning also will not be in a position to detect. It goes unnoticed, undetected. So that is why you are getting a echo vault. So you are surrounded by all the cloud echoes. A small portion is having no echo at all. That is called as echo vault. The second one is TBSS, that is the three-body scatter spike. Otherwise, in the literature, you can very well see flare echo. How it is coming in? From the radiometer, from the hydrometeor, not radiometer, because I was talking somewhere yesterday, I was talking something on satellite, that is where radiometer has come. Hydrometeor, from the hydrometeor, a signal is reflected back to the ground, and from again, from ground, it is reflected back to the same hydrometeor. By the time it has might move, then it will be flared out. So that is why you are able to say based on the cut. So all this echo, as if somebody is pulling from the northwest direction, it was having this set of orientation. So in the literature, if you search flare echo, some of the examples will be there. This is a classic example and a bookish type, which our Chandrasekhar and Bringi, when he visited at the time, when I showed him, he was saying that it is superb. That's what exact word he said. Now, earlier it was dragging in the north-northwest. Now I am showing north-northeast. Why? Because I have changed the orientation or the cut coordinates. And here it was going as high as, because I had gone up to the raw data, 62.9 dBz. Anywhere beyond 57 dBz is favorable as a hail signature. We have got beyond 60, definitely it is a hail of about 5 to 10 mm. So we have got 15 mm, whatever an Arakonam Navy has given, that is fantastically verified. So these two, third one is the upper level divergence. In the meteorology, we used to say lower level convergence and upper level divergence are vulnerable or favorable for the convective storm development, especially the CB developments. So in this particular case, the max V products, which normally we are not putting online, these are research mode products, which only in the radar meteorology we used to develop. You have positive, you have negative at the same height. So here also I made a cut. So you can very well see a positive color, a negative color at 18 kilometer, 16 kilometer, 14 kilometer, up to 12 kilometer. That shows what? There is a diffluence. There is a divergence. In the upper level divergence, which is vulnerable for or favorable. I will not say vulnerable. Again, earlier also I was using the word wrongly. Favorable for the CB development. That is fantastic. In addition to that, in the Raymer hailstorm, whatever they have used, and then thereafter Witt and Nelson in the US parlance, whatever they have developed, when the delta V is exceeding 46 meter per second, that is the divergence exceeding at the upper level 46 MPS, you have a hailstone signature of SLS, severe local storm, 19 mm. Now only recently it has been redefined as 25.4 with a probability of 0.8. So in this particular case also, it was very much favorable. And then that way only, we were saying that this particular Arakonam hailstone of the 30th, again, you can see that the previous day it was Villivakkam, very close to the radar. I could not get, there was no observatory. Here it was an observatory fact also coming, and then exact timing, size, etc. have been given. So we were rather joyfully working on, and then complete miniature data, we analyzed the threadbare. Ultimately, it was published as a paper. And severe hail index, this again the Nexrad build 8 algorithm. So maximum expected hailstone size. So this also in the algorithm part, probability of severe hail with a percentage. Everything has been put over here. Third hailstorm, and then this was probably, I got this picture only way back in 2005 when I was conducting an orientation program for our second radar in India, that is Calcutta radar. Though it was installed in 2002 along with the Chennai radar nearby, we conducted an orientation course after 3 years in 2005. At that time, this picture, when I was doing some work with the servers, I got this picture, and then with that only, then immediately I alerted my senior colleagues, Mr. Kundu Banerjee, and then my contemporary junior or something like that, our Pradhan. Everyone I suggested, this is a classic example. Probably on that day, there was not even a bit of rainfall. Not even a bit means hardly 1 or 2 mm could have been. It was purely a dry hail. No rain at all. And it is also a classic case because it has also exceeded 60 dBz. And this also has penetrated beyond 18 kilometer in this particular plot, might have gone to 22, 25. And all the parameters of radioson, they were favorable for that. In this particular case, the very fantastic feature of what I was saying, the echo vault, that is the bounded weak echo region or echo vault, that has been very much captured here. But unfortunately, this was not available with me in the real time. Probably otherwise I would have made a V-cut and then seen whether it was having the divergence part, and then maybe whatever we want to say, whatever we did for Arakonam, I could have done. Probably I don't know whether it has been published anywhere or something like that. This is also a classical case. Maybe in this particular case, it was very close to the airports. Probably had we known something like that, or even now also it is not late. If we know something like that, whomsoever is working for aviation, if they are seeing even the max CUSAT product, continuously watching, they will be in a position to alert the incoming aircrafts through ATC. Fourth storm, once again, Arakonam case. This was in 2005. Here again, the favorable parameters, T5 gram, everything has been put over here. Here again, the logbook entry, normally Indian Navy or IAF for that reason. So these data are supposed to be classified, they used to say, just because of my involvement with both the forces, that is defense forces, I got this one. Though they are recording in IST, in some cases I had changed into UTC. In this particular case, only for the time's sake, I am giving it. Otherwise, the same extract I am putting it over here. Here again, the maximum hailstone size estimated, probability of severe hail, everything has been put over here. So here is an animation from 908 UTC to 1238 UTC. You can very well see the Arakonum place where I'm putting that cursor. ARK is not marked over here because we are having different overlays. So that is why ARK is not there. That is one of the reason I have put the arc. So at this particular case only, that thunderstorm, hailstorm has crossed the Arakonum. So they are given some 1105. Perfectly, it is also matching here. We come to the end of animation. Last but not the least case of hailstorm, which is far away from Chennai. Because earlier I was saying about 8 km Villivakam or 65 km Arakonam, or I have gone to Calcutta, so which is far away from Chennai with that radar. Now with the Chennai radar itself, I am coming to Kadapa, which is about 225 or some kilometers northwest of Chennai. So you can very well see where is Kadapa. It has been marked as CDP. That also I have written over here for EC identification. In the animation, how it is going on, how it is passing on. And then in that particular area, why it is relevant? Because this area, the economy lives on orange cultivation, orange population. The very next day, on 25th April 2004, we got a paper news saying that Andhra, this particular area, lost a lot amount of orange and then it was a greater loss. For aviation, definitely whomsoever is flying, that will be around some 300, 340 for the domestic, or in case international probably, unless otherwise from Chennai it's taking off via that one, or from Hyderabad. Mostly for domestic, I am saying it is the worst case of 300, 340 flight level where is the core signature was seen. In case we know beforehand, we can very well alert the aviators through this. So here probably a vertical cut has been put because it is from Chennai radar. I was having the data, that's why I was able to play with that. So you have no echo below 4 km. The reason, earth curvature effect. Because it is 220 km away, even the 0.2 degree, it will be covering only 3.6 km. Even the beam width will be having about 800 meter or so. Okay, so that is why up to 4 km you don't have any echo. With the cut, what you are having it, the colors. So even the color, if you want to have, I inverted the color for pseudo so that, you know, you will be having a different distinctions. So hail signature was very, 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 very clear beyond 60 dBc. Now, after these convective storms, the second part of our lecture is the DWR wind related, that I am calling as low level wind shear and wind related parameters. So here again, a jovial cartoon by Reinhardt. So velocity folding, how the folding is coming out of the scope, radar scope. So nicely, fantastically, you know, here's the, probably, you know, we are not so serious that we should have some fun in life also. So that way I enjoyed this cartoon. Our folding is blue in red, red in blues. So now I am coming to the climax part, why I concentrated so far in convective storm. Federal Aviation Administration, way back in 1987, they analyzed all the wind shear systems. Out of 51 cases, they said that it is 33 cases only with a thunderstorm. That is one of the reasons I concentrated so far only thunderstorm. Because thunderstorm, as per VAPS, once we thunderstorm, we did not want anything beyond. It is having updraft, downdraft, turbulence, icing. So that is one of the reasons. So with updraft and downdraft, and with divergence and then probably in a convergence, etc., that also will be having a turbulent signature. So that is one of the reasons earlier we concentrated so far. So coming to the weather wind related turbulence, one is from the what you call convective storms. The second one is coming from front. The third one, order of magnitude I am saying, from the large scale wind forcing, surface wind, etc. And then the other one of equal magnitude is unstable air. Instability, if it is there, it will be inductive. And this is my favorite topic, atop inversion. So up to inversion, wind speed will be very less. Just after crossing the inversion, there will be a very strong, very sudden rise in wind speed. So that is one of the reasons it will be having a wind shear, and wind shear will end up with turbulence. Go here because my slide is getting saved. I want to see the caption, then alone I will be in a position to see. So now coming to this aircraft performance in regard to wind shear. In case the wind shear is acting up to 1 kilometer, the pilot has a zone, what you call presence of mind, he can avert it. A small view graph will be put over here. You can see that the wind shear is putting the aircraft down, but with the presence of mind, he climbs over. He again follows the same glide path. Right from outer marker, he is coming in. So glide path, above the glide path, it has gone, and then with that, he is able to still land better. The second one is when the wind shear is occurring at 0.1 kilometer. Now the second one is if the wind shear is occurring at 0.5 kilometer, what will happen? If the aircraft is pushed down, though he will be climbing to join the same glide path, he will be overshooting the runway. Now the view graph. These are all animation created by me in the PowerPoint only. Okay, so he is overshooting the runway because the headway is insufficient. The third one, when the wind shear is acting at a very lower height of 0.3 kilometer, he has no other go. He will be meeting with undershooting of the runway or just touching down the compound wall or even away from the compound walls. So here alone, that is one of the reasons ACARR in Annex 3, we used to say that the wind shear up to 500 meters above, most crucial, as per the Annex 3. In reality, we are considering 800 meters. Up to 800 meters, if you are in a position to alert the wind shear, probably pilot can be very, very happy. It is almost equal to why we are downgrading the QNH into the lower side. Because the pilot will be thinking that the ground is still below, whereas he might end up. In case the QNH is not lowered to the lower side of integer. Okay, with the lower side of integer, still a headway of 1 hectopascal, which is equivalent to 30 feet is available. That is why he is able to safe land. The same way, if you are giving an alert up to 800 meters, that will be fantastic. So now a small theory about turbulence, about 2-3 slides, how it is causing an effect and something like that. So this is the one of the thing. And then recent time also you might have seen the recent SIA, that is Singapore Airlines turbulence, which ended up forced landing over Hong Kong instead of going to Singapore. The flight was coming from London. So that sort of thing also we analyzed. That is like CAT in between two CV clouds. So coming to the turbulence, whether it is happening in the upper air or the lower air. So in the lower air also it can happen, whereas if it is happening in the upper air, we used to always say CAT, clear air turbulence. The Annex 3, what it says is that probably it is the responsibility of the incoming pilot. Whenever he experiences, he has to pass it on to the ATC, and then from ATC to Met Office, and then from Met Office probably we will be alerting for all the either incoming flight through our METARs for the next 2 hours, or till such time the another incoming aircraft says that it is no longer existing. So this is the procedure throughout domestic and international aviators throughout globe we are following on. And how to detect it? Low-level wind shear alert system. So this may be comprising of terminal Doppler weather radar. That is nothing but a radar which has to focus only on the runway. It should not have a cross angle. It has to focus only on the runway, which has to be installed about 8 kilometers away from the runway so that the side lobes, etc. will not cause any amount of what you call clutter signals. At least 8 kilometers away. But in most of the Indian parlance, we don't have any DDWR. Either space is not available or probably due to some restriction or something like that, we are unable to do. The DDWR in the global arena, hardly some 10 or 11 airports have. That's all. Beyond that, no airports have DDWR. We have a radar which may be orienting in a cross angle with that of runway orientation, not perfectly. Whereas DDWR requires that has to be oriented towards the runway only. But the DDWR also probably has a single runway or something like that. What it is preferable is that it has to be a non-scanning. If it is scanning, probably it may take 1 RPM or 2 RPM or something like that rotation rate. So in between turbulence, because the turbulence as per the theory, it may be lasting for a few seconds or few minutes. I am going to say for hours also. That is a different story. As per the theory, it has to last, or it used to last only for a few seconds to few minutes. So within that period, it might have gone out or something like that. That is one of the reasons. Even a single radar TDWR, if it is installed, it has to be a non-scanning type. Okay. As a single radar with a cross orientation, we have to do some jugglery. We have to make some algorithm with that only. How we are going to do with existing setup, that's what now I am going to cover up. And the turbulence as such in the case is very famous. maybe, right from 1920s, wherein the Richardson started saying that, bigger wills to little wills to lesser wills to viscosity. There will be the cascading effect of how the energy will be converted from the kinetic energy up to the thermal energy, and then there will be the turbulence is there. And the famous scientists, what they are saying, even including Einstein, probably when he was given a chance to work either on particle physics or turbulence, he chose particle physics because at least that is tractable, that is attainable. And there are scientists who said it is a classic unsolved problem in mechanics or physics. And another one, even in case I die, if I go to the day of judgment, etc., I ask the God to enlighten me. But unfortunately, I will not get any enlightenment or two aspects. One is the turbulent motion, another one is the electrodynamics. So such a thing is there. And now coming to the reality. From the wind, how we can estimate the wind shear, etc. Radially, you can have shear is nothing but what? Difference by the distance. It can be along the radial, it can be along the vertical, it can be along the elevation. So all three put together, either 2 in 3 or something like that, permutation combination, you can have any number of shears. One such shear which I was using in real-time mode was 3-dimensional shear, which is a concatenation or summation of a square root of radial shear square, azimuthal shear square, elevation square. And then here I have put some alert threshold, 16 meter per second per kilometer. If it is there, probably we have to be given there. But unfortunately, I am not in a position to extend the way in which runway. Only in one picture I have drawn the runway. You can very well see where I am putting the what you call animation. This one, probably the either black circle or something like that. That is the location of the airport, which is about 16.5 kilometers away from the radar center. So one prolonged wind shear case, which was quite active for more than 10 hours. And in between there was a lull, a break or something like that. Fortunately, whatever case I am putting, at least one wind shear should have been reported by some airline. That case alone I am putting it down. But not all the people will be reporting. Now you can see how the runway has been put out. 07 and 25 orientation. This is the runway. So how the red color is coming in. Red color is beyond 26. I am saying right from this yellow color onward, we have to give some alert means that will be fine. But again, for whom we are giving, it is only for the pilots. Most of the time, you will not get the feedback. This is not unique in India. This is everywhere applicable. Even with the Hong Kong airport, whatever they have done, they got a feedback at the order of 0.08% on campaign mode. Even with that, we are defining some algorithm because after all, we want to do some better job for the aviation community. When the community is not giving the debriefing, we cannot fold our hand because in case there is an accident, it is a loss for everyone. So that is one of the reasons. Probably even if it is not a feedback, we are trying our level best. My ordeal was right from 2002 up to 2006. 2005, I was posted in airport. 2002 to 2005, I was working with the Doppler weather radar. So from 2005 onwards, I was interacting with so many forums, including ICAO, IFALFA, that is International Federation for Airline Pilot Association, all these guys. And then everywhere they used to say, yes, whatever you are saying is right. But you have to understand our problem also. We are under tents for the safe landing. So during which period, either we may forget or we are postponing it. Afterwards, we will inform. Probably we got our own preoccupation, we are forgetting it. So both the reasons are probably very well received. This has been documented even by my great guru or friend, Professor Pravas Mahapatra of IISc, who has written a book, fantastic book, Aviation Weather Surveillance with a Doppler weather radar. And then in that book also, he has mentioned a statement. But I have mentioned this in my paper itself, 2004, based on the interaction. So the second case also, probably where they have reported, what is the airline they have reported, everything I have given over here. You can very well see whenever red color is there, it is beyond 16. And that was the case, at least one case was being recorded. So that itself justifies that, it is useful that way. The third case of wind shear. So here in the approach runway 25, that is the eastern side of the runway, how it is coming in, you can very well see probably this is the way in which you might have got the glide path. All the red colors are there, all the red colors. So that is one of the reasons at least one pilot has reported. This is what I have written there. Probably why the pilots, etc., they are unable to report sometimes. I had done a campaign mode in 2006, 2007 through the Regional Operation Committee Forum. We have given a piece of paper or information to all the airlines. Through the airlines, probably all the pilots have been told. So they have to mandatorily report 500 feet wind, 1000 feet wind, 1800 feet wind. And all the three, if it is reported, at least we will be in a position to get this here. Either one will be reported, or one will be absent, or two will be reported, third will be absent, something like that. So even with that, I have got some 6 or 7 cases that I am going to give in the next slide, how it is going to be there. So coming to wind shear, probably the turbulence. The turbulence can be estimated with so much amount of dynamic meteorology principle and other thing. And at the same time, through the radar, you are having the 3-dimensional shear or any type of shear, whatever is applicable to you. And probably, we can have some more informal way of doing it, probably by watching the radar in case there is a sea breeze coming in. Because the sea breeze convergence will be causing a turbulence. Whether it is qualifying the magnitude or not, that you have to watch. In one of the sea breeze cases, which I published in 2007 Pure and Applied Geophysics journal, page of. So that probably we are given very much, probably the sea breeze also was causing a concern. Now, how to get about this one? An aircraft independent parameter measured by AT dissipation rate by the aircraft having the provision for that. That has to be taken from the QAR, Quick Access Recorder, on board aircrafts. So that will be having even GB data or hundreds of megabit data that they will not be in a position to transmit anywhere. Probably that will be offloaded only when the cockpit from the data in the maintenance mode or something like that. With that only, probably Hong Kong, China was doing some project on this one. They were able to say, and ultimately ICAO Annex 3 right from 1996. So though I am giving the references 2007, 1996 to 2018, that is the latest book. So that also probably you are having all the different values, how they change the value based on minimal feedback we got it. And through NWP model also we can predict, though this is associated with the turbulence on spectrum width. Spectrum width also may be due to wind shear or due to turbulence. So that also you have to capture. Though I am saying it very easily, probably you need to understand this one, especially the book by Tatarsky of 1961, 1971, Russian author book, very, very abstract mathematics. When I was reading, Mr. Raghavan used to say, it is above my head, and then how you are reading, anyway, best of luck. Later on also in so many mails, he was quoting this particular paper, which I am just presenting here. Maybe all the 7 cases, whatever we got it, maybe what they have reported as moderate turbulence or severe turbulence, which qualified with the color 0.3 and above, it is a moderate, 0.5 and above, 0.45 now. That is what exact value recently they have come in. So that's severe turbulence. Only one value of moderate turbulence we are not in a position to get from the spectrum width. That will happen. There is a bit of salt we have to gulp it. So 6 out of 7 cases that was working well, though this may be contributing 0.001% of our aircraft operations. So this particular slide earlier also I have given over here. Once again I am giving here. So the last bullet is much meaningful for aviators. In the aviation literature, what we are used to say that moderate turbulence and severe turbulence, it is 3 meters per second in 10 flight level. 1 flight level is 100 feet, 10 flight level is 1000 feet or 300 meters. So which once you can translate, it is 10 meters per second per kilometer, that is moderate. If it is exceeding 20 meters per second per kilometer, it is severe. So what I have given was based on some studies, not with the 7, earlier also some studies, with that 16 meters per second per kilometer, that is the warning threshold, which we can say. Here again, the max, what is it called? The 3-dimensional shear product is almost like similar to max, is that only the plan view will be shown. We have to estimate the maximum value of azimuthal elevation shear and radial shear. And then particular value, you have to pick it up for each pixel and then you have to project. So that way only 3D shear product will be giving some guidance. Only thing we have to put along the glide scope, which the radar supplier will not give, we have to do. Though I was trying my level best, I could not implement. After going to Delhi in 2015 also, I tried my level best through some NWP person and other thing, probably whomsoever is having better computer jargon, and then they will be using it. Still then we were unable to do, but it's a good topic, one can do something on it. What the pilots need? pilots need, maybe what they are going to have is either increase in wind or decreasing in wind, either loss in wind or gain in wind. So this is the ribbon type of display they want to have. So this is possible. That is what I was saying. Along the radial scope, you have to do like that. This is my vision. So with that only probably we were working on. And then along this one, probably the aircraft can land over here or land over here. We have a cross runway also, 1432. This way also we can do. In case you are having parallel runway, each parallel runway you have to do like that. So along the glide path, if you are in a position to pick up the wind, and then if you are in a position to estimate the three-dimensional wind shear or elevation wind shear or radial wind shear, similar to mimicry of DDWR, even with a single radar, one can do. Only thing we have to do something systematically and then do. So I admit my folly. I tried my level best due to my own eyesight, because at the age of 42, I got my cataract. Left eye is almost 50% gone. Right eye also I have a problem. So that's why I left the screen at this stage. Though I am presenting here because it is for the younger mind to take up this way. Probably with this, you can have some idea with that. Now I am giving with my own work how the wind variability within the boundary layer, atmospheric boundary layer, planetary boundary layer, whatever we are having it with that. So with the different heights, how the wind is getting changed. If the wind is getting changed with the direction and the speed, it is nothing but a shear. If it is along the glide path, definitely it is vulnerable. Now, after the wind, I am just coming to precipitation rate. Prior to that, probably, one more family which I have forgotten the earlier, thunderstorm, severe local storm, cyclone storm, there is a tornadic family. So here I want to concentrate, because with a single radar, you will not be in a position to have in case the radar is beyond 100 kilometers. The reason being, so the tornadic storm, once it is coming down, you can very well say this may be some few tens of meters or few hundreds of meters. If you go to 1.5 kilometers above the surface, it will be around some 1 kilometer or 1.5 kilometers. So that definitely you will not be in a position to get with the scan resolution bin volume. So in order to have the bin volume, what Nextrad was having, every 100 kilometer, they have installed a radar. So that 50 kilometer one radar will see, another 50 kilometer another will see. Even with a 100 kilometer, they will be in a position to get, provided it is coming close to the radar. So up to 50 kilometer, definitely tornadic storm can be detected in case it is coming close to the radar. And probably this point we have to understand. That is why these two slides I am putting it down here. Now coming to the last topic, we have three topics only I said. One is the convective storm case, second one is the wind case, third one is the precipitation and associated visibility case. So the precipitation rate, probably what we can say is, we can have the Marshall-Palmer equation or something like that. With that, we can fine tune for Indian condition. There are tens of thousands of A and B parameter, Z equal to AR power B. And India, we are doing only one. Especially India means I am saying only about Chennai, wherein I work now. And then probably, with the accumulation, wherever rain gauges are, they are given in the names, three-letter word. Wherever rain is occurring, it is not over the rain gauge. So that is why I am saying it appears as if rain is eluding the rain gauges. So with the Z equal to AR power B, what applicable for India, applicable for Chennai in India. So this has been published in Mausam, and then with that, probably whatever is there, some 4-5 slides, the validation. It is right from 2002 last, maybe sometime in November and December, I started this work. And till 2014, when I was working in Chennai, it was validated on a real-time basis, continuous basis, 80 to 90% of efficiency we used to get. So with that only, all these particular cases, whatever I am saying, it was able to capture a low rainfall of, that is, heavy rainfall is more than 65, and probably very heavy rainfall is more than 12.5 centimeter or 125 millimeters. Everything has been captured well. What else we want? So with the rain gauge ground truth also we have validated, and it has captured even 47 centimeters. That is 47 centimeter, 470 millimeter, when the system was not associated with any depression or cyclonic storm. So depression, cyclonic storm also we verified. A streamline flow or stratiform flow, that also we verified. Convective case also we verified. So this is a particular classic case wherein a peak rainfall of 470 mm, 490 mm over Tambaram IIF, and in Chennai airport itself 45 mm. Everything has been given. You can match the color. Almost we are nearby. Here, the lower than heavy rainfall that has also been captured. So far I was saying heavy, very heavy, exceptionally heavy. So ordinary case also we can very well see very 10 millimeter, 20 millimeter that also has been captured well. Why I am concentrating this 4 slide? Now the climax is out. This is useful for estimating the visibility. For that only I am going to come. So for estimating the visibility, what we need it, we used to have a transmission meter installed in the airport. That works on the optics principle. And probably that is the instrumentation at both the ends of the runway. We should have one each. In the middle of the runway also we should have, depending on the Cat 1, Cat 2, Cat 3. In some of the airports like Delhi, we have 5 transmission meter also because fog is very prone in Delhi with a 50 meter and less. Continuously it is going on. That is why we are given even any number of transmission meter on a particular runway. So that way probably transmitter meter will estimate the runway visual range, that is the visibility as per the pilot's knowledge when he is about to land at the central line of this one, how far he will be in a position to see, that is RVR. So this can be estimated the drop size distribution which can be measured by the radar. So the DSD can be measured by the disdrometer, wall focal disdrometer, and then any other optical disdrometer, etc. You are having it. So that way also we can have. With the radar data also one can have. So with the DSD, the moment generating function has to be given up. In short, in statistics, MGF. So the MGF can be computed. The order 2 is optical extinction. The optical extinction is used in the visibility estimation, the transmission meter that we have mimicked here. So with that, probably the visibility can be estimated in relation to almost like V equal to Z AR per B, the same way. There, it was reflectivity related with the rain rate. Here, visibility related with the rain rate, where R is the rain rate. So this rain rate, I am giving in a tabular column, how it is coming in. Beyond 45 dBc, which corresponds to some 35 mm per hour, which is lower than 1 kilometer visibility, that is 860 meters. As the dBc increases, so naturally 60 etc. may not be the rain, it may be a hailstone. But 60 dBc also can be rain provided it is just 0.3 kilometer down below. That will be rarest of rare cases. Normally the rain will be confining to 50, 52. Beyond that, it will be a hailstone or small ice crystals. Okay, that is why I have confined here only up to 50. So even by 50, you are coming to 480 meters. As I told you, the category type 1 of runway, which will be as per the ACARR knowledge, ACARR guidance, is 550 meter is the bare minimum needed. So that is why I can say here 50 dBc, I have restricted over here. So this particular thing, I want to just compare with the real-time story, which in the convective storm, I told you, I will come to the last one, penultimate one for this cyclonic storm. This is a Varda cyclonic storm. That is why item number 1, that is the convective storm case. Item number 2 is the wind shear. Item number 3 is the precipitation rate and visibility. So now I have squeezed in Varda cyclone of 2016. So you can see the cyclonic track path after its finalization. You can see almost like an India map. What is this one? This is a QNH plot. That is the pressure plot. The bare minimum pressure was 974 millibar on this particular day when the storm was just crossing little north of Chennai. And during that period, probably whatever METAR was there, you can very well see how the wind was there, 50 knots gusting to 70 knots. By this time, probably the airport was closed already. On that day, even 4 hours, the airport was totally closed before it was approaching here due to high surge in wind, etc. So in this particular case, the METAR, etc., whatever I am giving, I am repeating here. Here, why I am repeating? Because the visibility I am highlighting here. So visibility of 500 Cat 1 category. So yeah, probably Chennai is having Cat 1. Definitely, no pilot can land. Okay. It is not having Cat 3 type. So naturally, no aircraft will be landing. So prior to that itself, 6 UTC itself, we have stopped this particular runway in operation. It went for more than nearly 4 hours. So this 100 meter visibility, that with the rain rate of 50 dBc, and this one probably this also probably I am giving in a nutshell how it is useful. Now last case with this I am winding up, maybe 4 slides maximum. So in this particular case, maybe December fag end, 27th to 28th of December up to March, and a particular year 2002, 2003, we were having continuous echoes in the morning and afternoon. And the echoes were after the size of 28 to 30, which corresponds to 1 to 12 millimeter per hour. And then with that, probably one can estimate that it is raining. But unfortunately, none of the observatory, either managed by IMD or state government or defense, none has recorded anything, including AWS. So if that be the case, where from the echo has come? So that is a curiosity. With the radar, because all I am saying in 2002, we commissioned the radar in 2002-2002. So during that period or prior to that itself it started. So that is why we dedicated right from installation of 30th September 2001, we were doing it. And then ultimately I am just showing with authenticity how it was. So this sort of what you call echo will be misleading an aviator as if it was raining. And moreover, we increase the elevation beyond 4 degree elevation. Now, no cloud was there. If that be the case, whether it is only a stratus cloud which is passing on. But unfortunately, none of the observatory was recording any rain. So if that be the case, where is the source? So I am looking at the source. Then I integrated over a period of time for 3 months. So it was having more than 60 centimeter in particular places, more than 10 centimeter. If that be the case, it was a welcoming relief for a water-starved city like Chennai. Chennai always have water scarcity. Though water everywhere in Bay of Bengal, drinking water is very, very scarce. So it will be a welcoming boon, but unfortunately not even a single drop was there. If that be the case, this is nothing but a spurious echo. Then what is the source? So the source has been analyzed. With that, we come to know that probably it was the time, etc., which was coinciding with the civil twilight and nautical twilight. It is the time at which the birds will be starting from the roosting place for their murmuration, and then maybe their own living for prey, etc. They will be traveling all. So it is nothing but the birds movement ornithology study. So different types of what you call birds have been given over here. What radar reflectivity we have? It is mm power 6 per meter cube. So that being a huge number, we used to say DBC 10 log 10 of that particular value. There are few more factors which we used to say equivalent reflectivity factor, which is based on the volume reflectivity. That is zeta E and eta. This also the 1990 40th Radar Met Conference, 874 pages of book. I advise everyone to read, whomsoever has not seen it. So it is having right from Passerelli algorithm of digital signal processing up to aviation. Complete 31 chapters, 31st chapter is aviation. Okay. So now the birds starting time, ending time, and then all this twilight time, everything has been given. Ultimately, what are all the sources, etc., how it has been contributed. I analyze the refractivity structure constant, which we used to do for ST radar, MST radar. So that also was not giving this set of signal. That was very, very low signal, not matching with 25 dBc. Ultimately, birds and insects alone. In the literature, Actamer has published 40 dBc from the insects. He has not mentioned about birds. Insect may be a mosquito. Insect may be a dragonfly, very small. What I am saying is the bigger birds, egrets, wingtails, they are all very, very lengthy birds. Definitely it has a stomach. Within the stomach, you are having moisture. With the moisture, there is a discontinuity. Radar works. The reflectivity is being given only from the moisture discontinuity. That is why you are getting the signal. Ultimately, we got it. So this is my last slide, if I am right. So with the rain rate, what Professor TNK, I was saying in the second slide, probably he used this particular, this one, Thane cyclone. I think Thane only, if I am right. Yeah, Thane cyclone, he has used it. And then he was able to capture the realized rain rate very close with the physical institution of the radar rain rate, whereas without, that is your control run, was far low. So improvement is quite possible. It is not, though he has published way back only in 2016. I think it was in 2013 when he came to Chennai. At that time, he was expressing his idea. Then I suggested him. At that time, probably he said, I have not seen that paper. Tarbell 1981, in one of the aviation met conference, he has published a 4-page paper. He has presented that one. It came as a publishing. I happened to go through that one. And later on, 1983, he has done as a published paper in MWR, Monthly Weather Review. So those references I have suggested. Ultimately, TNK himself was saying that yes, it's a good idea. Physical installation. What Tarbell was doing at the time, it was only with satellite based. That is a coarse resolution. 2.5 degree by 2.5 degree, 1 degree by 1 degree, that is 100 kilometer by 100 kilometer or 250 kilometer by 250 kilometer, 1 pixel. Whereas in the rain rate, what we are having is 1 kilometer by 1 kilometer or 1 kilometer by half a kilometer, depending on the range what you are looking at. Okay, so that way definitely it will be having it. So this is the ever latest murmuration around Chennai, how the birds are coming. So these set of birds definitely will give 25 dBc, and then you will be fooled that probably as if it was raining. Now, in a nutshell, as a meteorologist, we have to do something on forecasting, whether it is a non-aviation forecasting or aviation forecasting. We have to nowcast thunderstorms. Even if you give a very short range forecast, it may come true, may not come true. That is the order of the day. Even our dynamic model with current day, though we are claiming 3 kilometer by 3 kilometer, 9 kilometer by 9 kilometer, I got my own reservation to say like that. At least 27 by 27, we are in a position to get it. But again, it will be at a time and distance separated out. Because even now also we are unable to fix 95 centimeter rainfall in 2005 Mumbai. Probably we are able to predict about some 200 to 500 kilometers away from Mumbai or 3 to 6 hours away from the actual occurrence. So that is the order of the day. We have to bear with that. Even with the dynamic meteorology, NWP model, etc., until otherwise we have a location specific model. We tried even the local area models like MM5. That was the day probably all people they were saying MM5 are fantastic. After some time it has gone unnoticed. Then WRF, AWRF, ARFs, RAMs, you say any name. Okay. So these are all having its own limitation, but the resolution wise, if our processing capacity, model running capacity with computing, IT technology ever increasing nowadays, unless otherwise it is installed with 100% predictability, we have to sustain our living on aviation forecast. One of the Reinhardt cartoon also, we have been watching because we have been paid. So we have to have a continuous watch. With that only we can now cast. So the empirical model will be having its own say. Each station specific model with the conventional radios on, radar and satellite, etc. one has to attempt. And then ground-based radar product, that's what I was already covering. Satellite also I had covered. Now, the tropical convection order of the day is normally, cap is one area. In US, etc., with 1000 joule per kg and maybe a sign of 50 joule per kg and less, they are favorable even for tornado for them. Whereas in tropics, especially the coastal belt of India, right from Calcutta up to Chennai or even below Chennai, you have 4000 joule per kg, not even a single CB cell is developing. Then what else it wants? Cap may be necessary, but not sufficient. So the sufficiency will come depending on hygroscopic nuclei to be present, instability has to be there, then it has to be put in a shell which works like a conditional instability of either first kind or second kind. And then within that, the data also you have to punch in, you have to foresee the CFL condition of computational instability also. With that only we have to bear. So I am putting up end with the famous quote by Bernard Shaw, people who can, definitely they will be doing it. Who cannot? Sorry for my academicians. I am not meaning anyone because it's the Bernard Shaw quoting, teach. Because they are unable to do. But who can do? Who cannot do or who cannot teach? What they will do? Probably research. So that is the order of the day. Whereas we have to show that we can do, we can teach, we can research. Thank you.
Thank you very much, sir, for an exhaustive and wonderful talk regarding the application and the need of further research in DWR, where you have shown that many of the empirical models which you have developed for Chennai, so and other aviation purposes, that should be scaled up for other local conditions as well. So it's a very nice presentation and a very exhaustive presentation. I don't know whether all students might have deeply understood. Otherwise, we have YouTube recordings. So it will be placed in the SAMA website. You can go through 1 or 2 or 3 times to understand all these things. Yeah. So thank you very much, sir. Now I request all panel members. Sir, please, can you please
Minimize.
unshare? Yeah.
Unshare. Okay.
Yeah.
Where is that one? Maybe if I think minimize only, it will be right. Like last time. We are unshared, there is no option coming in. I am minimizing it. I am minimized.
Okay.
I already minimized.
Okay, sir. Okay, sir. I close from my side. So yeah. Now I request all panel members kindly switch on their camera to have one photo. Suresh sir, you are not visible. Is it possible to?
Yeah, where is this one? My video is on, but again, I don't know why it's not coming in. It's not cut. It is on only. But why my photo is not coming in? That's not a problem. I don't want any photo. It's on only. It is not cut. You can very well see.
Yeah, Sama logo is seen.
Huh?
Sama logo is seen.
Yeah, only your logo is seen.
Yeah.
So
okay, anyway, that is also good. Your name is there. Dr. Rohini, can you please? Yeah, please. Yeah. So I think Sagada, you are taking screenshot. Okay. 3, 2, 1. Thank you. So now we are moving towards question answer session. I request Dr. Rohini to moderate this QA session.
Thank you. Thank you, Dr. Suresh. It was such a wonderful, informative lecture. I'll go with the questions immediately. So the first question is, does thunderstorm leads to ionosphere irregularities?
thunderstorm needs to ionosphere.
Irregularities.
Ionosphere I have not covered because basically we are working only for the troposphere and then exceeding tropopause, only that much. So in the ionosphere thunderstorm, I don't know where from the question comes in. Probably the thunderstorm will penetrate even up to some 23 kilometers. So and definitely it will not go to ionosphere. Probably whether it has any influence on ionosphere, if you want to ask, probably you have to ask some of the MST radar usage specialists, maybe right now PB Rao or someone, maybe even current NARL director, I have forgotten his name, but it starts with P. Okay.
Yeah,
So,
sir, we have an observation of ionospheric disturbance during a thunderstorm event. We just published that. We are sharing that.
with the ST radar or MST radar?
ST radar.
Yeah, that's what I'm saying. So what I'm saying is a tropospheric radar.
Yeah. So we are just sharing in chat
That's why I
box.
told you.
Yeah.
ST radar and MST radar, ionospheric probably influence with the thunderstorm, which is well confined within the troposphere. That may have this signal. I think Professor Mohan Kumar from CUSAT, he also did some work. And I have forgotten that NARL person's name. He is the director now. But he starts with
AK Patra, sir.
Right.
Yeah. So during that time, some kind of sprite which propagates from ionosphere, kind of a wave activity, like that wave can perturb the ionosphere F layer. So we got some.
You mean gravity induced waves and other thing, right?
From the top of the thunderstorm, there is a traveling disturbance which is propagating upwards.
There are 50, 60 papers published by NARL group with the MSC radar data. I am aware of some other thing. Probably my cup of tea is not on ionospheric propagation.
Yeah, we are sharing our papers on the
Okay.
chat box. Yeah.
Okay.
Rohini, can you please?
Yeah, I hope he must have got his answer. So the next one is how you calculated the hail size from radar data.
Yeah, that I told you, NextRad build 8, build 9 algorithm. You can search with a NextRad build 8 or build 9. Build 9 is the latest one which I have used. I don't know whether they have increased to 10 or 11 or something like that. Build 9, you can very well see. There are papers bit at all. That reference I have given in my PPT.
Okay, sir.
NextRad build 9 bit at all. Or the bit.
Okay, sir. Next one is what are the major challenges in forecasting using radar products? At any time has your forecast failed? If yes, why?
Yeah, I think one of the cases which when the local forecast, thunderstorm forecast means probably it has element of doubt. Maybe 80% or 85% success you will have. Beyond that, it is very difficult. In one case, I told you, even the eddy dissipation rate, the low-level wind shear case for the observed itself, though it was not a forecast, even the observed itself, it was failing. What was the reason? We have no idea, because the basic governing physics of meteorology is so complex. It is not like Ax equal to B and then Cx equal to D, one can solve. It is nonlinear. With the nonlinear unpredictability, theory of chaos, nonlinear dynamics, that one has to understand. Dynamic meteorology or nonlinear dynamics, one has to study. So as far as I am concerned, maybe somewhere between 70 and 80% we were having success.
Okay. Next one is, sir, in our case, hailstorm and lightning are common weather events. What radar application do to lightning detection application?
Maybe lightning detection, there are separate sensors. Radar detecting a lightning also is possible. Probably for that reason, you should have the scan strategy properly defined. You should have very slow rotation rate, maybe less than 1 RPM. Then what radar? Say for lightning, it will not come on its own. It will come only with the CB. It will come only with the thunder. So when thunder and CB is there, definitely there will be moisture particle available. So if high moisture is there, our X-band radar or for that reason even C-band also is not that good. S alone is good. The wavelength has to be somewhere around the order of that 10 centimeter, which we are having it for the tropospheric radar. Beyond that, the cloud radars, etc. So that also we can have it. Whereas if you use a thunderstorm radar like a 3 centimeter X-band, definitely you will not be in a position to get a lightning strike, because the signal is getting absorbed with a heavy amount of precipitation, hail signatures, or heavy DSD, drop size distribution, water sizes. So that will absorb the scattering energy. So that is why you will not get the returning pulsation. So that is one of the reasons. For each application, there are separate radars available. As a biomedia, for cyclone tracking, what we are having is S-band radar, sugar. S for sugar, 10 centimeter radar. For thunderstorm alone, if you are just having it mere cloud, X-band radar is sufficient because it is less costly. S-band radar, which requires a huge antenna for 1 degree beam width or lower than 1 degree beam width, it is very costly. A biomedia is C-band. Most of the countries now they are going in for C-band because thereby they can estimate the precipitation also. They will be in a position to peep through the cyclonic storm. X-band will not peep through the cyclonic storm through the eye of the storm, whereas S will peak. A biomedia of C, which is cost-wise also mediocre, between X, which is low, S, which is very high. So this is a mediocre one. And probably no C-band radar also we can have it. For pure application of mere lightning, you have to go in for 10 centimeter and above, like that. Now coming to the lightning detection, as I told you, there are separate sensors available that one has to take care of. Is there any other question in that?
Not regarding lightning as it, sir.
Right. Then I think hail you are saying.
Yes.
So the hail probability, etc. That again probably any of the radar will be in a position to say the hail signature. Estimating the hail stone size, probability of severe hail, PASH, severe hail index. So that all requires maybe a reflectivity which has to come very clearly. So that reflectivity has to come clearly means you should have complete calibration. So the calibration, whether it is a X-band radar or C-band radar or S-band radar, one has to do very meticulously. Okay, so that way we have to see. For mere identification, any of the radar will do. For estimating the algorithms, whatever I have shown, yes will be better.
Thank you, sir. Yeah, the next one is, what is DBZ cutting point for the airport to be closed down?
Please say again.
What is the DBZ cutting point for the airport to be closed down?
See, based on DBC, no airport can be closed. Based on the cyclonic wind fury, then alone the airport has to be closed. Okay, mere DBC, etc., it will not be. Mere DBC, anytime it will be there. With the thunderstorm, anything it will be there. With the thunderstorm, definitely they can circumvent and then come to the runway, unless otherwise it is right over the glide path or over the runway itself. Okay, with the thunderstorm, as a byproduct, you are having the downdrafts. So that will be diffluence. So that will be having, initially they will be facing the headwind, thereby they will be getting a lift. Again, they will be applying the power. They will come to the glide path. Again, there will be a downdraft wind, which is a tailwind, which will be pushing it down. So this sort of thing only we have to have. Wind is the phenomena for what you call aviation or aircraft operations, not the DBC. For closer of the airport, whenever a cyclonic storm comes in, depending on the wind speed, if it is favoring within the headwind of 30-35 knots, with caution, they will be landing. Same 30-35 knots, if it is a tailwind, no aircraft will land. If the crosswind of even 15 knots, 20 knots, no aircraft can land. So that orientation of the wind alone matters for closing of the airport or suspending the aircraft operations. Got it?
Okay, sir. Yes. Next one is, during flight, if thunderstorm develops and an aeroplane can't change path, which altitude is preferred for flight?
During flight, if the aircraft is seeing a thunderstorm,
if a thunderstorm develops and it cannot change its path, which altitude is preferred?
naturally they have to change the path. They will be doing it. Cannot change, will not come unless otherwise it's a huge MCS or mesoscale convective systems, mesoscale convective complex, or a huge blob which may be stretching for some 500 km by 1000 km. That will be very rarest of rare. But even then also they will be circumventing, they will be away from that. But how far they have to be away, that also matters. Even in case they say that, if the thunderstorm is only up to some 9 km, 300 flight level. So they can very well go for 360 flight level or 380 flight level, not 320 or 340. A safe separation of 20 flight level, that is equivalent to 2000 feet, has been suggested as a very, very bare minimum. But in reality, not less than 10,000 feet or 8,000 feet, one has to be away. And in the recent SIA accident, one fellow died, and then so many people had on some injury with the turbulence and other thing, which landed at Singapore in the month of May. In that particular case, it was 2 CB cells in between the flight was going. It was having a very, very narrow corridor of 60 nautical miles. Within the 60 nautical miles, there was no CB as per the satellite picture. Within that, they were peeping in. But still then, the severe turbulence has happened. They lost an altitude of 6,000 feet in 23 seconds. Okay. So that is why I used to suggest 8,000 to 10,000 will be a safer margin, because the moment you are having loss of altitude, probably, with the presence of mind, with the pilot, co-pilot, something like that, they will try to meander. So avoiding thunderstorm, if it is a single, definitely they will be circumventing. If it is a huge blob, then also they will be circumventing. For that reason, extra fuel has been advised based on your BAPS charts, SIG weather charts, SIGMET warnings.
Next one is, which case is more dangerous? Thunderstorm while landing, thunderstorm while taking off, or thunderstorm during flight in the atmosphere?
See, while taking off, it depends on if it is over the runway or away from the runway. Whereas while landing, it is much more once it is on the glide path, and much severity right over the runway at the touchdown point or the middle of the runway, etc. Because there will be diffluence, there will be divergence which is coming from the bottom of the CB cells. In flight, as I told just now, I finished off, above the top of the CB clouds, because on board there is a radar with the aircraft. They will be seeing at what height the CB cell will be there. If not, already they have been advised by segment warning or sigma charts. So they will be definitely going at least 40, 50 or 70 flight level at the top of the low minimum. So in one of the slides, I have made a purpose mention, I think 5th or 6th slide, 40 dBc is the one which the manufacturer Airbus and Boeing, they advised the pilot to be careful as far as possible, avoid. This answers this question and the earlier question. Thunderstorm means 40 dBc and above. At what height, that again matters. So because he is flying around 240 flight level or 300 flight level or 390 or 430, there the 40 means it is very severe, really. If it is 240, maybe just like that, baby thunderstorm or something like that. So if it is going beyond 9 kilometer, 40 dBc, naturally they will never venture in. And then there is one more reason. In 2 of the hailstorm cases I told you, maybe the bounded weak echo region wherein there is a severe updraft which even the radar cannot capture. So in that particular case of updraft, if it is extending to some 5 kilometer, if the aircraft is going like that, what will happen? He will be pushed within the thunderstorm. Okay. So that is why whenever a sigma weather chart is given or a sigma warning is given, pilot has to take care and then he will try to avoid. The more safety has to be ensured by the pilot rather than the advising people. All the input will be given by the metaphys.
Sir, the next one is, can we track locust swarm using
Local storm means local severe storm or
no
severe
locust, the insects, locust swarm.
Oh, locust, okay. LOCUST, locust. You can very well have, that's what I'm saying. For that, the signal has to be sufficient enough for you. So the signal can be even from your C-band radar or S-band radar. Both are possible. C-band radar and S-band radar both can track your locust or insects. And here one has to read, as I told you, as my great person who spent on his life totally, Raghavan, the Tatarsky book. It is hardly about some 38 pages. Second book on 1971 was 71 pages. It took more than 1 year for me to understand such an abstract mathematics. That has been translated by so many people after 1970, 1980s, etc. Even Mahapatra book, Doviak and Zrenich book, and Savajo of European countries, all books EDR, eddy dissipation rates. So that one has to study, and then with the turbulence also we have to decipher it with the what you call spectrum width, which may be arisen due to spectrum width arisen due to turbulence or wind shear induced. So that way also you have to decipher. Everything has been listed. So that's why Ragan used to say that that particular paper which I have quoted, had I been in your place, I would have produced 3 papers instead of 1 what you published. Okay, because there I analyzed the pros and cons of including refractivity structure constants. So with that, how much it will contribute? With the equivalent reflectivity factor, volume reflectivity of the bird size, its stomach size, how it will contribute, how much it will contribute. If that be the case, how many birds will contribute a particular pixel value, that you have to do. So this took a year for me to publish that paper, to analyze the do with the postmortem analysis of all. Okay, so insects travel, there are groups, radar ornithology, people can search through the literature.
So the next one is, can we use ST radars for wind shear turbulence calculation? Is there any intercomparison of these studies with conventional DWR?
Definitely, ST radar can be used for wind shear, but again, it is for stratosphere. What so far I have been concentrating is only troposphere.
There is another one, sir, which says that, can you elaborate more on the recent flight accident due to turbulence in Delhi airport?
Say again, insect flight.
No, the recent flight with turbulence in Delhi airport.
Probably, today already, with so much of the reservation only, I accepted this 1 hour program. Okay, because I got my own way, the current way of my working or something like that with the eyesight problem, etc. So the recent one is that SIA 321 flight from London to Hong Kong, which stopped at Singapore. Then the next day, not next day, within 5 days, another flight, that Qatar Airways. In the first case, as I told you sometime back, 6,000 feet altitude drop in 28 seconds with more than 1.2, 1.8 G drop or something like that. And I collected some of the what you call insert pictures, etc. And then in the course of talk itself, I told about 60 nautical mile corridor. So within that, either probably the logged on data with the, there are so many, you can very well search, probably Umsor is working with aviation, you are aware of. Flight Aware, there is something, and then there are some other URLs also available. Flight Aware is also a good site. You can get the flight data, maybe with free subscription for about 7 days, up to 7 days you can have. Beyond that, they will not give. Probably you can register and then it's a paid subscriber also you can have. And with that, the quick access data recorder also from the concerned airline, you have to take it, then you have to analyze. In this particular case, within 2 or 3 days, I started analyzing, looking into, but unfortunately, even the insert picture is not available nowadays in the real-time mode. So through some of my known guys, because earlier I was working with IMD, some or other I got some of the insert imagery pictures. Then ultimately I found out that in about 60 nautical mile corridor, there are two clusters. One was on the western side, another one on the eastern side. This flight was going in between. So whenever there is a CB, the outer topmost part is having annual cirrus. Beyond annual cirrus, you are having something like maybe the wind shear. So the wind shear, that particular thing, if it is not associated within the convective cloud, that is called as CAT. CAT definition itself, clear air turbulence. The turbulence which is not in association with the convective cloud, or the turbulence which can be felt in the clear air. Though the pilots community or somebody, they will be saying that it's an air pocket, it's purely a misnomer. There is no word called air pocket in meteorology. It is nothing but the turbulence which is arisen out of not in the vicinity or not within the CB clouds. In this particular case, the CB tops were there, where he was facing, it was about 5,000 feet above. So naturally, I got reasons to believe that it was only a cat. I think one professor from UK also, he was publishing in one of the posts. Maybe he was also saying that it was cat. Now, actual postmortem analysis, the airlines company, the aircraft company, they'll be publishing. I advise whomsoever asks the question, please go through the literature. You get an answer with that. As far as I am concerned, it was only a CAT which was in between two wild CB cells separated by some 40 to 60 nautical mile corridor.
Thank you, sir. The next one is lightning hazardous for aviation?
Lightning?
Hazardous for aviation.
Lightning naturally, it will cause a blinding eye for the pilot whenever he is flying, and then probably, just he will be facing a spark of light. Do you know what is lightning? Lightning is nothing but the discharge of electricity. It is nothing but the potential differential force PDF. It has an order of magnitude 3 megavolt per meter in case of dry environment, 1 megavolt per meter in case of wet environment. In the case of CB, it is a wet environment. When such a potential difference exists, it will be causing a sudden pass of electron to go in a very faster speed. Maybe it is traveling in milliseconds and microseconds, or in the worst case, a few seconds. Had it lost for even 1 minute, its catastrophic effect will be because it is producing 10,000 ampere as per the thunderstorm project, which I quoted way back of 1949, 1971, 1990. There are at least some 20 books on thunderstorm project published by US. So in those, they have very nicely documented. So lightning will cause a high discharge of electron, which cause a sudden flash of light, which may result in blinding vision. Momentary, not necessarily permanent blind. Second one, it produces a current which is 10,000 ampere. Through that, it will be warming up. So the warming of the molecule does not have enough time. It will explode. The exploding effect with a cascading, it will come to 60 dB, 100 dB, 80 dB. So this is the effect of lightning.
Thank you, sir. The next one is, do radars employ any special filter to detect spurious echoes on screen? If so,
Yeah, every radar, even earlier radar also we have. I think that's why I told in one of the slides, whenever you see a product, straight away don't jump into and then don't use it. It is not necessarily radar, it is applicable for satellite also. You have to see what are all the parameters, what are all the legends. So in any radar, you see the legend. Nowadays, the current radar manufacturers, they are reducing the number of legends. Earlier day, whatever I was showing in 2002, 2005, 2010, up to that, you have enough parameters. Out of that, 2 or 3 are very much useful for this particular question to answer. One is that SQI, that is Signal Quality Index. Second one is the CSR. Third one is the threshold. Okay. So all this one probably, we have to have some idea, we have to apply. In case you want to have a good quality signal in regard to velocity, SQI has to be more than 0.25. This also comes from the 40th Radar Met Conference 1990, edited by David Atlas, American Met Society Radar Met Conference. So I told you 874 pages. There are enough literature available. So new radar, old radar, everything is having. Only thing you have to understand what is the legend, what we are looking at. So spurious SO can be filtered based on this. In addition, there is another facility, earlier radar also what I was showing, we were having it, clutter mapping. So on a clear day wherein there is no echo at all, you have a map, you have a scan around. You take all the permanent echoes, maybe a building, maybe a rock, maybe a mountain, maybe a hillock. So that will be contributing huge echoes. So those echoes will be non-moving. Radial velocity wise, it will be 0. Okay. So those things you have, that you apply as a filter. So in that particular area, you just put it there, and then along with the reflectivity, whatever is improving there, you have some algorithm for that is called as clutter filter, clutter map algorithm. So that also one can use. As of now, I told you 3 points. One is the settable parameters like SQI, CSR, and threshold. Second one is clutter filter. Third one is clutter map. So the notch width also matters. How the Doppler notch width can be used. That also is the fourth point.
sir, we'll take this last question. What are the conditions in which the thunders do not produce rain despite maximum reflectivity of 40 dBz or more?
What are the conditions at which the thunder will not be produced despite the reflectivity is there, correct?
Yeah, rain, yeah.
See, the reflectivity, there is no order of magnitude as such. Though we are saying 40 dBc, 45 dBc is the one, maybe up to a height of, not even up to, at a height of 6 km, which is well above the freezing level on any season. Suppose if it is a winter season over the extratropic or even over northern pocket of our tropics, India, etc., even 4 or 5 kilometers will be the freezing level height, or 3 kilometers will be the freezing level in deep January, February, winter season. So any reflectivity above the freezing level, if it is 40 and 45, naturally it may produce thunder. If it is lower than the freezing level of 40, 45, definitely it is not producing any thunder. So you have to correlate with the freezing level, the particular season, and the order of magnitude up to what extent the height goes. So that way only you have to see.
Thank you, sir. And there were many comments like the talk was very interesting, and also on suggestion of different books which you have already done in your lecture series. So thank you, sir. Over to you, CUSAT team.
Thank you, Dr. Rohini, for nicely moderating the QA session. And thank you, Suresh sir, for the nice talk and nice interaction with the participants and clearing their doubts. So it was a wonderful session from you, sir. Thank you very much. And now I request our Sama President Tyagi Saab and our Radar Meteorology course chairman, Dr. Pradhan sir, to have some few remarks on the talk.
This is a formality, Abhilash, probably whatever I have done, that's all. You want
Okay.
to complete the formality?
Yes. So then now I request Dr. Swagata to propose the vote of thanks so that.
Thank you, Dr. Ravilas. But if I can be co-host, it would be good. Then I can share that template, I could say.
Oh, okay. I made you supposed. Yeah.
Yeah, it was
Okay.
there. Yeah.
Yeah, now you are.
Yeah, now I got it. Now I hope it is shared.
Yes.
Uh,
Not in full screen.
okay. So, esteemed guests, distinguished speaker, and respected colleagues, as we conclude the 8th lecture of the Radar Meteorology series, it is my privilege to extend our heartfelt gratitude on behalf of the South Asian Meteorological Association, also the Advanced Center for Atmospheric Radar Research, CUSAT, India. We are deeply grateful to Dr. Devendra Pradhan, Scientist G and former DDGM instrument at the Indian Meteorological Department, for his dynamic welcome address, and to Dr. Poulomi Chakraborty, postdoctoral researchers and climate educator, for our introduction of the speaker, Dr. R. Suresh. Our sincere thanks go to ABM retired Professor Dr. Ajit Tagisha, President of SAMA, for his inspiring opening remarks, and to Dr. R. Suresh, Scientist Staff and Deputy Director General of Meteorology at IMD, for his enlightening lecture on the utilization of DWR products in aviation. We also appreciate Dr. Rohini L. Bhawar, Assistant Professor at Savitribai Phule University and active ECT member of SAMA, for moderating the question and answer session, and of course Dr. S. Abhilash, Director of ACARR at CUSAT, coordinating the entire series. Finally, thank you to all participants for your engagement and contributions. With our heartfelt thanks and best wishes for a splendid day ahead.
Next, no? Thank you, Swagata.
You are welcome.
I also thank you for proposing the formal vote of thanks. Thank you very much.
Yeah.
So we will be meeting on 20th July for the 9th lecture series, which will be delivered by another eminent radar meteorologist from the same Chennai radar, Dr. S.B. Thambisar. So we will meet on 20th at 3 p.m. 20th July at 3 p.m. again. Thank you very much for joining. Thank you.
Thank you, sir.
Okay, goodbye. Thank you.
Thank you, sir.